Hi guys, today we're going to review slope-intercept form and how to graph equations that are in slope-intercept form. If you take a look at the equation y equals mx plus b, m always represents the slope of your graph, or the slope of the line. It's how much y increases or decreases as x increases by 1. B represents the y-intercept, the place where your graph crosses the y-axis. Whenever I graph equations, I always go to my y-intercept. I like to call it the starting point. Let's take a look at some actual equations so I can show you what I mean. In the equation y equals 3x, I can actually see that I have a slope of 3 next to x, and I don't have plus or minus anything. That means that my y-intercept is 0, so I'm just going to add a plus 0. Anytime you see an equation like that doesn't have a y-intercept, that means the y-intercept is 0. 0 is my starting point, so I'm going to go over on my graph and find that coordinate, 0, 0, and plot my point. Now that I have my y-intercept, I can deal with my slope. Slope is always a measure of how much y increases or decreases as x increases by 1. So 3 represents how much y changes. So my slope is 3 over 1. Something you might have seen is that if it's positive, your line's going to go up. If it's negative, your line's going to go down. So what this means is from my y-intercept, I'm going to go up 3 steps and right 1 step to get to my next point. So let's do that. Go to my y-intercept. I'm going to count up 3, 1, 2, 3, then I'm going to count right 1, 1, and drop it off. I'm going to do it again. Up 3, 1, 2, 3, and right 1. I only have half of a graph right now. I want to go this way too. If I want to graph lines to the left of my y-intercept, I follow my rule backwards. So instead of going up 3, right 1, I'm going to put my point on the y-intercept and go down 3, left 1, down 3, left 1. And I can see that if I connect these points with a straight line, or with a line rather, that it creates a straight line. This is a linear equation. Let's take a look at another example. Y equals negative x minus 2. In this equation, negative x is my slope, and that is 1x, so there's an invisible 1 there, so my slope right now is negative 1, and my y-intercept is negative 2. I always want to start with my y-intercept. That's my starting point. So on my graph, I'm going to find where y equals negative 2, and I'm going to put a point there. Y is negative 2, put my point there. Now, I'm going to graph my slope as an expression of rise over run, or how much y changes as x increases by 1. This means, because it's negative, I'm going to go down 1 and right 1. Go over to my y-intercept, down 1, right 1. Down 1, right 1. Down 1, right 1. If I want to go backwards, follow the pattern backwards. Up 1, left 1, 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 and so on until I fill up my graph. Let's take a look at one more example. This one I want to look at a fraction. In this example, my slope is a fraction. So what this is saying is as x increases by 1, I would go down 3 halves. To make this easier, from our y-intercept, we're going to go down 3, right 2. But I'm getting a bit ahead of myself. Let's look at our y-intercept. My y-intercept is positive 2, so my starting point on my line is positive 2. Find the y-axis, find positive 2, and drop off your point. Now I can deal with my slope. I'm going to go down 3, right 2, from my y-intercept. So count down 3, 1, 2, 3, and right 2. 1, 2. Drop it off. Down 3, 1, 2, 3, right 2, 1, 2. Down 3 would get me off my graph, so I'm not going to do one. Let's go back to the y-intercept and go backwards. Up 3, left 2. All right, and once again, I have a beautiful straight line, which means this is a linear equation. Your turn to practice.